Jamias, and my partner is Jungjae, and today we have our EC327 project, and our inspiration was to connect statistics with programming. This project creates a graphical user interface for a machine learning algorithm that lets users upload a dataset and builds a simple classifier for them to clarify new images. Our objective is to explore and visualize the math that goes on behind the scenes when a machine learning algorithm is executed. So let me just walk through the execution. So if I type in make, okay, so it's already up to date. Then we see that this is the graphical user interface. So here it says the prompt is enter directories of files containing image data. So that means directories that contain vast amounts of JPEG pictures. So my first directory, actually let's take care of the default case. So if I just click train, then an error will pop up, and then if I do fill in the labels, then it will go to the default setting, which is a included cats and dogs filter, or not filter, file in the actual project folder. So once it takes its time loading, and here we can see that the program outputted an average cat image, an average dog image, the training and testing error using linear discriminant analysis and quadratic discriminant analysis, and a 2D plot representing each data point of each cat and dog. Now, if we input a different directory, so let's say typed in the directories containing the MNIST dataset containing of the handwritten or quote-unquote handwritten numbers. Once we press train, it will start training the dataset. And now that the machine learning algorithm has finished, we can see the average 0 appearing the average 1, the training and testing error for the different methods of error, and all the data points of the 1s and 0s condensed or reduced into 2 dimensions. Now, in this example, I'll train the model to learn 3 and 9. One thing that I haven't mentioned before is that these JPEG images are 24 by 24 pixels wide, meaning that there are a total of 784 pixels in each picture. And behind the scenes, what the machine learning model is doing is that it's taking all of these pixels and condensing it, or not condensing it, but rearranging it into a 784 by 1 vector. And it is combining all of these vectors together to create a matrix, and from that matrix, it will do arithmetic operations on it. Now here are the results, and as you can see, one thing I haven't talked about before is how we get the train/test error graph. So we see that the graph is a function of dimension, and what that dimension is basically how many things that the model quote-unquote remembers. So like I said earlier, the model remembers 784 pixels of each image. So let's say that the dimension was 784, then the training error rate would be 0 because it would remember every single picture. But the testing error rate would be really high because it wouldn't know what to do in an actual real life scenario, or quote-unquote real life scenario. So we need to minimize both the loss of both the training error and the testing error. And from this, we can determine that the training error and testing error minimum is around 50 dimensions.